Hey everyone, and welcome to another video. Today we are diving into the fascinating world of open source intelligence, commonly known as OSINT, and focusing on one of the most popular and effective tools in the industry. We are talking about Sherlock. Now, before we get deep into the mechanics, I want to be absolutely clear about the scope of our discussion today. We will not be showing a practical live-fire demonstration or any terminal hacking exercises on real targets. Instead, we are focusing purely on a comprehensive tool overview, discussing its underlying architecture, its purpose, and strictly how to utilize it in an ethical manner. In the realm of cybersecurity, ethical boundaries are the foundation of everything we do. Tools like Sherlock are incredibly powerful, but with that massive capability comes the strict responsibility to use them for defense, auditing, and authorized footprinting. Sherlock is a robust, open-source tool written in Python that allows you to hunt down social media accounts by username across thousands of different social networks. It is an absolute staple in the reconnaissance phase of a penetration test or an authorized red team engagement. But how does it actually work beneath the surface? At its core, Sherlock is elegantly simple and entirely non-intrusive. It does not exploit vulnerabilities. It does not attempt to bypass authentication mechanisms or break into servers. It simply automates the tedious process of checking if a specific profile URL exists on the public web. When you create an account on a platform like a specialized forum or any mainstream social media site, you are usually given a public profile page that incorporates your username directly into the web address. Sherlock relies on a massive community-maintained configuration file. This file contains the URL structures for hundreds of different platforms. The tool takes the target username you provide and systematically appends it to all of these platform URLs. It then sends a standard HTTP GET request to each of those potential profile pages, mimicking the behavior of a normal web browser. If the remote server responds with a 200 OK status code, Sherlock flags that as a positive hit, meaning the account likely exists. If the server responds with a 404 not found error, the tool simply moves on to the next site on the list. The ethical application of this methodology is primarily centered around digital footprint analysis and brand protection. As security professionals, we routinely use Sherlock during engagements where a client has specifically asked us to map out their public exposure. Sometimes, corporate employees use the exact same username across their personal gaming platforms and their professional development environments. This overlap can inadvertently lead to severe social engineering risk, allowing a potential attacker to build a detailed psychological profile. To truly understand the value, the output, and the analytical process of this tool without running a live attack on an unauthorized target, let us conceptualize a deep dive search using my own handle. I want to see exactly where my digital footprint extends across the internet. For this detailed overview, we will look at the comprehensive search for my username, ethicalexplorers18. If you were setting this up in your own authorized environment to audit yourself, the syntax is incredibly straightforward. You would simply open your terminal, ensure you have the required Python dependencies installed, and type the command, Sherlock ethicalexplorers18. That is the entire command, just the tool name followed directly by the target handle you are authorized to investigate. When you execute that command for ethicalexplorers18, the tool immediately springs into action and the terminal begins to populate with a clean, color-coded output stream. You'll start seeing lines appearing one by one, each representing a successful discovery. The true power of the tool reveals itself in real time as it concurrently queries over 300 different websites simultaneously, utilizing asynchronous requests to speed up the reconnaissance. Imagine watching the screen as it methodically lists out the findings for ethicalexplorers18. First, you might see a green hit indicating a successful discovery on a major developer platform, confirming that a code repository or developer profile exists under that specific name. Then, a few seconds later, the terminal logs a positive result on a popular microblogging site, followed by a community discussion board and perhaps a specialized cybersecurity forum. The output is exceptionally clean. It doesn't just tell you that it found the username, it provides the direct clickable hyperlink to that exact public profile. This conceptual process for Ethical Explorers 18 highlights a crucial aspect of passive reconnaissance, which is user consistency. People are inherently creatures of habit. When someone finds a digital username they resonate with, they heavily tend to stick with it across the board to maintain their online identity. By identifying that Ethical Explorers 18 exists concurrently on a coding platform, a casual social media feed, and a niche hobbyist forum, a security analyst can begin building a highly comprehensive behavioral profile of the subject. However, professionally analyzing this outfit requires a highly critical eye. Just because the Sherlock tool mathematically flags a URL for Ethical Explorers 18 doesn't automatically guarantee it's actually my profile. False positives are an everyday reality in open source intelligence. Sometimes poorly configured web platforms respond with a 200 OK status code, even if the user doesn't exist, simply because they redirect all invalid requests to a default login page or a custom search page instead of properly serving a 404 not found error. Therefore, an ethical investigator never just blindly accepts the terminal output as undisputed fact. They must manually click through the generated links for Ethical Explorers 18 to manually verify the content. They meticulously look for matching profile pictures, analyze similar biographical descriptions, check for overlapping geographical data, and read public posts to confirm the identity with a high degree of confidence. That conceptual walkthrough of the Ethical Explorers 18 search perfectly encapsulates why Sherlock is both brilliantly effective and incredibly eye-opening. It takes a tedious manual process that would normally consume countless hours of an analyst's valuable time and elegantly compresses it into a matter of minutes. But with this incredible efficiency comes a stark and necessary reminder about digital hygiene. Every single account you create on the internet expands your personal attack surface. Every forgotten, unmonitored profile is a potential piece of the puzzle that a malicious threat actor could utilize to craft a highly targeted phishing campaign, answer your security questions, or attempt a credential stuffing attack on your active accounts. This is exactly why running automated auditing tools like Sherlock on yourself is not just for professionals. It's a critical step in personal cybersecurity. You simply cannot effectively defend your digital perimeter if you don't know exactly how wide it extends. Remember, the definitive distinction between an ethical security researcher and a malicious threat actor always comes down to authorization and intent. We utilize these powerful tools to proactively discover vulnerabilities and data exposures before the bad guys do. We use them to educate our fears, to audit our systems, and to secure our networks. You must never run automated reconnaissance tools against a target without explicit, documented permission. I hope this comprehensive overview gave you a solid, foundational understanding of what the Sherlock tool is, how it intelligently functions under the hood, and how to approach open source intelligence gathering responsibly. Mastering these concepts is a vital skill for anyone looking to enter the professional cybersecurity field, or for anyone simply looking to take proactive control of their own sprawling digital footprint. Stay curious about the technology around you, stay strictly ethical in your practices, and always keep learning.